Alright then, welcome back everyone. Let's solve this question, monsters. Now, this is a very interesting question. I guess this was tagged as constructive algorithm. But the fundamental ideas that this question uses is just amazing. So quickly summarize the question for you. So in this playlist, I'm focusing more on summarizing the question than reading out the question, and that this trend will follow for the later series, just to keep the video length as short as possible. So assume that you are reading the question and coming to this video. Okay, fine. So the question says we are given n monsters and the health of a monster is defined by AI. So ith monster is a health AI. Now what we want to do is like this monocarp's character has ability that deals K damage to the monsters with the highest current health. So what we want to effectively do is we want to kill all the monsters. But in one blow, what we can do is we can deal a damage of K to a monster with the highest possible current health. However, if two monsters have the highest health, what we do is monster with the smaller index is preferred. Fine. So we are given n monsters, each of them has a health, and in the end we want to kill all the monsters. But in a blow deals a damage of K to the highest, like to a monster with the highest current health, and the smaller index one is preferred. Now, a monster will die when its health has become less than equals to 0. That's what they have written. And determine, like the output, what they're expecting is determine the order in which these monsters will die. Right? So, what you have to output is you want to output the indices of the monsters in which they die. And the important thing is this is one based indexing because the monsters are numbered from 1 to n. Fine. So, I guess the question is clear. Now, let's move on to the observation, right? So, what observations can you make here? Now, let's see what observation can you make. Now, slowly and steadily, we are into, you can say, some easy medium level category of questions on competitive programming. So it pays well that you develop abstract thinking. Now, understanding the question by examples worked very well for 800 and 900 rated questions, and it will also work for 1000 rated questions to some extent. But I don't want you to teach wrong. I want you to develop the correct mindset. If I solve the questions by examples and by not giving you proper proofs, it won't be fair for you. Right? You will understand the question, but you won't be able to generalize well. So what there will be a common trend in this playlist and the coming playlist that I'll teach you how to develop an abstract level of thinking, so that you just don't solve this question. You are ready for solving other similar kind of questions, right? So I'll try to use I'll use examples. There's no doubt in that, but I'll try to make sure that you understand the question using just observations and abstract thinking, or maybe some formal or informal proofs, because that is what will give you the most benefit of this video, right? Fine. So enough about that. So let's make some observations. So what observations can you make in this question? The first observation is very simple. When you pick up a monster to deal a damage, pick up in the sense you'll pick up a monster with the criteria that they've given, right? So highest current health, and if there are more than one monster highest current health, you pick the one with smaller index. First observation is when you deal damage to a monster, it dies when its HP is less than equals to K. HP means health, right? So that's very simple, right? When you decide to blow damage to a monster and its health is less than equals to K, it's gonna die, because in one blow you're gonna deal K damage. So this observation is there. Fine, not much here. What is the other observation can you make? What you're doing is you're always dealing a damage of K, right? So let's say our healths are like this: A1, A2, A3, so on till An. You're always dealing K damage, right? So maybe let's say first time you deal a damage here, then you deal a damage here, then you again deal a damage here, then you deal a damage here, so on. So what you're seeing, I'm always dealing damage as a multiple of K, right? So the total damage, like the way it is happening is at a given time, the damage dealt to a given monster is always in multiple of K, or in other words, the health reduction always happens in multiple of K, right? So health reduction is in, you can say Kx, basically multiple of K. And that's not very difficult thing to observe, right? So you're always dealing a K damage. So this AI at a given point of time. So in the end, we have to kill all the monsters, right? So at a given point of time, this A1 will become A1 minus some multiple of K, right? And when this A1 minus some multiple of K has become less than equals to K, in the next blow it will die. But all in all, my main concern, like the main observation here, is the damage always happens as a multiple of K, right? So that is what I'm trying to say. Fine. So this very thing, these two observations are very simple. What next? Hear me out. This is a very interesting observation. If you are able to make it, then you have pretty much solved the question. So hear me out very attentively. All the monsters will be alive till at least one of them has HP greater than K. Right? So don't worry. I'll give you an example why it works. So let's just take an example. K equals to 5. Okay. So we deal a damage of 5 per blow. And all the monsters will be alive till at least one of them has HP greater than K. Fine. Let's see. Let's take an example. Let's say the HPs are like this: 3, 4, 1, 2, and maybe 16. Fine. So you can see here, one of the monsters has health here greater than K. Fine. So this is the monster that will pick, right? So the 16 will become 11. Still 11 is the highest. This 11 will become 6. right? Still 6 is the highest, greater than k, right? And this 6 will become 1. Fine. So now what you saw is till at least one monster existed with the HP greater than k, greater than 5, all the monsters were alive. This observation, this third observation, directly follows from this observation that a monster will be dead in this current blow if its HP has fallen below k. Now, if you are picking up a monster and you know for the fact that it's going to be dead now, how are you picking it up? Picking it up. First of all, it has to have the highest possible current health, right? So monster will be picked up and it will be dead in this blow only if all the other health has become less than equals to k. So what it automatically means is there is at least one monster with HP greater than k. No monster will be dead. The monster won't be picked up unless all the other monsters has HP has become less than equals to k, right? Because it has to be the highest possible current health if it has to be picked up. So if at least one of them has HP greater than k, of course all the monsters will be alive. Fine. I hope you got it. It's like it directly follows from here, right? So fine. So these are the three great observations. So what it happens is, so initially, so now you have these three observations. This is a very good observation. So this is a good starting point. Now what do you think? So initially you have your health like A1, A2, A3, so on till AN. So you have made your observation. A monster dies when its HP becomes less than equals to k. Health reduction is in multiple of k, and all the monsters will be alive. At least one of them's health is greater than k. Fine. So that's good. Now how do you think the final healths will look like? So I'll take an example here. Very simple. Let's say k equals to 5 again. Now all the monsters will be alive until at least one of them has HP greater than k, and then greater than k means greater than 5. Now the monster will start dying when HPs have become less than equals to k, right? So you can say I'm writing down here how my health area will look before final n blows, right? So you know for the fact that all the monsters will be alive till at least one of them has health greater than k. So let's just figure out the case where all of the monsters health has become less than equals to k. So after this one, after n blows, all the monsters will die, right? Cool. So it can look something like this. Maybe 2, 3. I'll write all the health less than equals to k. 2, 3, 1, 4, maybe 5, or let's say maybe one more 2. Cool. So this is how it can look. So right now you can say in final, this is how my health area will look before final n blows, right? Do you agree with me here? Because till at least one of them had a health greater than k, you could not kill a monster. But after this is the configuration. After n blows, all the monsters will die, right? So how do you think this configuration came? By the way, how do you think this configuration would have come? Like what is like? How do you come up with this configuration? 2, 3, 1, 4, 5. So I just told you the final configuration will look something like this. So all of this health, so all of this will be of course less than equals to k. This you agree with me? Fine. From a third observation, this you agree with me. All of the health will be less than equals to k. But how do you think this 2, 3, 1, 4, 5, 2 came? What was the second observation? The health reduction always happens in multiple of k, right? So from A1 you removed some multiple of k. From A2 you removed some multiple of k until the value was less than equals to k, right? So from A3 you removed some multiple of k until the value was less than k, like less than equals to k. So how do you think this came? This 2 came. So after removing some multiples of k, you are not able to remove k, and you are left with 2. After removing some multiples of k, you are not able to remove k, and now you are left with 3. Does that sound like a modulus operator to you? It did to me. I hope it should sound that to you as well, right? So how do you think this 2 would have came? This 2 would have came like A1 mod k, that is 5. This 3 would have came like A2 mod k, and because you're always dealing damage in multiple of k, right? So if the health has fallen below k, what does it mean? It means the health has become A1 mod k, right? In this case, if it is 5, what it means is this AN is a multiple of k, right? K is 5 here, right? So this, if it has become 5, this AN might be a multiple of 5. So what I'm saying, guys, is see, if you have healths which are k was 5, right? That's what you're talking about. If you had healths which left a remainder of 1, let's say 11, then what else? 21, and this leaves a remainder 1, right? Is a remainder 1. Then you have, let's say 12, 22. This leaves a remainder of 2, and let's say 13 and 23, then 14 and 24, and let's just say which leaves a remainder 0, 20 and 25. So if you trace it out for yourself, I'll leave it as a homework to you. If you trace out the way the damages are, like the blows are dealt, you will find out that the final array before you can say last n blows will look something like this. For this you will have 1, 1. For this you will have 2, 2. For this you will have 3, 3. For this you will have 4, 4. And for this you will have 5, 5. And this is very, like, this directly follows from the fact that the health reduction is a multiple of k, right? So this is the abstract thinking, and this is the example. I leave it as an exercise to you. You can trace it out for yourself. I guess we have been doing this for a long time. So fine. So the main idea is before the final n blows, all the values will be less than equals to k. And what are these values? these values will be simply ai mod k. And if it is a multiple of k, then it will be 0. Like in that case, it will be simply k, right? So if it is not a multiple of k, then that value will be, so what I'm saying is, the before the final n blows, the value will look something like this: ai mod k, if ai is not a multiple of k. Otherwise, it will be k if ai is a multiple of k. Fine. So in this case, it will be 5, right? Because 20 mod 5 is 0. Fine. So I guess you got it, right? So this is our final array will look like ai mod k if ai mod k is not equal to 0, or k if ai mod k is equal to 0, right? So before the final n blows. Now the death order is very simple now, right? What is the death order, or the order of death? It will be simply first you kill. So like if you have this array, so after you can say after n blows, all the monsters will be dead. So now can you figure out how are you gonna, like, what is the order of monsters? Of course, the one with the bigger value of ai mod k will be dead first, right? So first these guys will be dead, and then the bigger value of ai mod k will be dead. So that order will be simply first kill all the monsters with ai mod k equals to 0, okay, followed by uh, followed by follow this order of ai mod k, right? Descending order, of course. This will be in descending order, right? So this is fine, right? So first all the monsters which are multiple of k will be dead first. Of course, the index rule will figure it out, but first all the monsters which leaves a remainder of 0 with k should be dead first, right? Because in the final, before the final n moves, they will be having the highest values, right? And followed by that, a mod k, like then the order will be followed by a mod k. This will be in descending order, right? The one which leaves a remainder. So then first these guys will be dead, then these guys will be dead, then these guys will be dead, then these guys will be dead, and then these guys will be dead, right? And the index order, that we can figure it out. So the point is figuring out the order, right? So this implementation detail is more of a how do you implement it. You can maybe use a comparator, or it frankly depends on the programming language that you use. But coming to this part, so how do you come to this part? By making these observations. Once you make these observations, you are able to figure out that before we deal the final blows, our health array looks like this: ai mod k when the remainder is not 0, k where remainder is 0. Now if you have this, if this is how the array looks, you already have the picture before the final n moves. The order is very simple: first kill all the ones with ai mod k equals to 0, and then follow the order of ai mod k in descending order. Fine. So I guess that's that. Let's see the implementation. I'll show you one good implementation without comparator. Okay guys, let's quickly code it up. So I've already taken the input. Now what we need here is we need to find out this, right? So we need to find out the health before the last blow, area of I mod k, because the death is going to happen in this order. Of course, when it is divisible by k, we will make it k. So any which way, whenever area of I mod k is 0, I'll make it k. So we'll have the numbers between 0 to k minus 1, right? 0 to k, sorry, 1 to k. And then we can store it and sort them in descending order. But we need to also consider the index into picture, right? So that's why I'm created this array which will also store the index, right? So that's why this array is, let me just store all the health before the last blow and the index. So I less than n, I plus plus. So I'll show you like how can you achieve this. So first of all, if array of I mod k is 0, then what it means is the health before the last blow would be, what will be? It will be k, right? And index I for now, okay, I'll come back to this. So for now, we're just storing index as it is. Else, the health will be what? The health would be area of I mod k, because always we are dealing in multiples of k, right? So I, fine. Now we have the health before the last blow, right? So the health before the last blow, it will be somewhere between 1 till k, right? Because of this part, right? Otherwise it would have been 0 to k minus 1, but now it is 1 to k. Fine. So what next? You need to sort it, right? So there was no constraint about like the index, like lower index should die first. I could just simply sort it like this. And now what will happen is the monsters with higher health will be at the end, and I can start killing, like I can start killing from the end, right? Basically, that's what I can do. However, here we have a constraint that smaller index should be dead first, right? But if I sort it like this, what will happen is the monster with larger health will be at the end, and with a larger index will be at the end. So how can you nullify that? Instead of storing I here, just simply store minus I, right? See, I did nothing. Basically, if I just sort it like this, what will happen is the monster with larger health will be at the end. However, when monster health is same, the larger index will be at the end. So I can simply store minus I here. So now what will happen is minus 1 will come after minus 2, right? So now when you come from the back, you can first kill the monster, like monster with index 1. It will show minus 1, but you can simply print the absolute value, right? So it will be very clear. So I guess whenever you have to consider this index while sorting, you can always get away by not using a comparator, by just storing it minus I. You just have to think a little bit. However, I think it makes sense. So let me just print the answer now. So what I'll do is I have the monster sorted in ascending order. So I'll come from the back. I equals to n minus 1, I greater than equals to 0, I minus minus. And now what I need to print is first what we need is, right, hp of index of I dot second, right? So this should be under absolute value, right? So that's that. So hp of index I will be the index, because we want to sort the order, right? And here it will be zero base. That's why I'm just putting an absolute value. That's why I'm adding 1 to it. Absolute, because we are storing negative indices, right? And that's that. There should be space, right? So I'm doing nothing. I'm just going through. I'm sorted the array by monster health, and smaller index will be at the end. So I'm coming from the end and printing the absolute value +1. +1 because we are stored in zero base indexing, but we want 1 base indexing. And then I can just print new line. It seems to be working. Let me just quickly submit it. It works. Thank you for watching. I'll see you in the next one.